First of all, I thank Indonesian Journal of Electrical Engineering and Computer Science for giving this opportunity to present my paper. My paper title is Enhanced Vegetation Encroachment Detection Along Power Transmission Corridor Using a Random Forest Algorithm. The authors are Deepa, Somasundaram, S. Nivetha, R. Shalinirajan, Santhi, Karuppiah, and then R. Sudha. The abstract of my paper. Vegetation encroachment along power corridor poses significant risk of infrastructure safety and reliability, necessitating effective monitoring and management strategies. This study introduced an innovative methodology for detecting vegetation encroachment using a combination of manual and automatic process integrated with the random forest algorithm. Issue of vegetation encroachment is critical as it can lead to power interruption and safety hazards if not addressed promptly. The objective of this paper is to develop a scalable and effective, cost-effective solution for vegetation management in power infrastructure maintenance. The methodology involves manual patch extraction and labeling to ensure the accuracy of the training data set combined with the automatic feature extraction technique to capture relevant information from satellite imaging. Leveraging the random forest algorithm, the model construct an ensemble of decision make tree based on the extracted features and then achieving robust classification accuracy. Finding from this study demonstrating the proposed approach enable consistent and timely identification of vegetation encroachment in new satellite imagery. Stored model parameter facilitate efficient training testing, enhancing the system ability to provide proactive interactions. This scalable solution significantly reduces reliance on manual labor and offer a cost-effective method for continuous monitoring, ultimately contributing to the resilience and safety of power transmission infrastructure. Introduction. The background is power transmission lines are virtual infrastructure that can be disturbed by environmental factors including vegetation encroachment. Encroaching vegetation can also lead to power outages and safety hazards. Signification of the study. Existing reduction methods are either labor intensive method and then the need for scalable, automated and cost-effective reduction methods. The research aim is, the proposed aim is, paper aim is to develop the vegetation reduction system using satellite imagery and machine learning, specifically the random forest algorithm to enhance the monitoring efficiency. This is the transmission vegetation management. Here inside the right, the figure shows the transmission row management. And then the problem statement here, the main challenge is to vegetation growing near the power line increases the risk of power disruption safety concern. Current method and limitation, manual method is time consuming. LIDAR and SAR imagery, it is effective but expensive, limiting large scale application. And then NDVI vegetation method requires multispectral data which are not always be available. So the proposed solution is using a high resolution satellite imagery and machine learning model to automatically detect and monitor vegetation encroachment. The objective here is develop a scalable model that accurately detects vegetation encroachment using satellite images. And secondary objective is to automate the feature extraction process from satellite images, ensure high classification accuracy and efficiency with the random forest model, reduce dependence on manual labor for monitoring tasks. Literature review. The vegetation reduction method, yeah, that is first, NDVI and EVI are commonly used, relying on spectral property of plants, and then stereo satellite imagery used to estimate object heights around transmission line. Limitation of current methods, you need a high data acquisition cost of LiDAR and SAR, limited availability of suitable resolution stereo imagery, and then NDVA requires specific multispectral data which is not always accessible. So the proposed approach is to leveraging high resolution visible light imagery and random forest algorithm for a more accessible and cost effective solution. Methodology. The first here, these are the steps. First one is data collection, satellite imagery of transmission line corridors, and then manual extraction of image patches near the transmission line. And then after that, you have to label it, labeling the patches as vegetation encroachment or no encroachment for training. Feature extraction, automatic extraction of textural, spectral, and statistical features from the labeling patches. And then model training, train the random forest algorithm on the labeled data to classify vegetation presence, testing and prediction. Use training model to predict encroachment in new image data patches. Here, next we discuss about random forest algorithm. First, what is random forest algorithm? A supervised machine learning algorithm that creates an ensemble of decision trees. It uses multiple trees to improve classification accuracy and reduce overfitting. Advantages: handle high dimension data well and provide accurate prediction, robust against overfitting, especially with the complex data set. Why random forest for vegetation reduction? High accuracy in classification task, suitable for distinguish between encroachment and non-encroachment vegetation area using textural and spectral features. This is the block diagram of the proposed method. First, the data collection and pre-processing. From satellite, you have to get the data, and then manual patch and extraction and labeling. It will be feed to automatic feature extraction, and then by using random forest algorithm, you have to train the data set, and you have to predict the whether the vegetation is grow within the row or outside the row. Implementation steps. The manual patch extraction. So satellite images are manually segmented to isolate area near transmission lines, and then labeling. Each patch is labeled based on the presence or absence of vegetation encroachment, creating a ground truth data set. Automatic feature extraction. Extract relevant image features such as textural and spectral attributes using OpenSCIVI and Scikit library, learn libraries. Random forest modeling training. Train the model random forest classifier on labeled features. Parameter storage. Store model parameter and rules allowing for efficient feature testing without retraining. And next we discuss about result and analysis. Here comparing random forest algorithm with SPM model. Here comparing with the SPM model, the random forest algorithm accuracy is 0.8, whereas in SPM it is 0.8. And then precision is in case of random forest it is 0.82, whereas SPM is 0.78. And recall value is performance. These are the performance metrics. Okay, and then recall value is 0.87 for random forest, and for SPM it is 0.82, and F1 score is 0.84 for random forest, whereas 0.8 for SPM. From this, the key findings are the random forest demonstrated superior classification performance compared to SPM, and then high precision recall indicate that fewer less positive and negative, making it reliable for real world deployment. And then visualization shows the convection matrix or a bar chart to illustrate this matrix. So this is the simulation output of vegetation encroachment reduction along the transmission line corridor using a random forest algorithm. Here, if the vegetation is nearer to what transmission line corridor, then it will, if it is based on the distance, okay, it will give, it will represent the value. Okay, green line indicate what the transmission, it will be in terms of percentage, the values are what indicated. Next discussion. Interpretation of results. Random forest high accuracy supports its viability for automated vegetation reduction. Advantage over traditional method. It is a cost effective and scalable compared to LiDAR and manual ports, and continuously monitoring enabled by automatic turning, feature extraction and classification. And then resource allocation, enable prioritization of vegetation management resource based on identified risk areas. And then conclusion is this approach provides a scalable and accurate vegetation reduction solution, reducing cost and enhancing monitoring efficiency. And here you can achieve high classification performance with random forest, automation of previously manual task, facilitating proactive vegetative management. And then broader impact is to improve the pass transmission reliability and safety by addressing vegetation risk. Here the future ORCIS experiment with the other machine learning algorithm, example CNN for finding image detail, and then integrate additional image feature for spectral band for better accuracy, and then real world deployment, incorporate with a real time monitoring system for automated alerts on vegetation encroachment. And scaling is adopt the model for diverse geographical location and vegetation type to generalize beyond the initial data set. And then these are the references I have used for this paper. And then next one is I'm using used ML model. In that I'm using a random forest algorithm to train the vegetation encroachment in transmission line corridor. Here I'm using a RoboFlow website to find solution for this one. Okay. Here I'll the next video proceeds with the how to simulate the vegetation encroachment in the transmission line corridor using a random forest algorithm using a RoboFlow platform. Uh, Thank you.